Hello, my name's Brock. I'm a technical architect, and thank you for giving me an opportunity to solve Packt Lightning utilities for you today. An overview of Packt. They're a European electric and natural gas company offering B2B and B2C services across 40 cities in the European Union. They're looking to digitally transform and offer modern customer-centric solutions with minimal cost to serve, and they're looking to implement Salesforce as a CRM and unify their global sales and service business processes. A couple of risks that I've identified. Their ERP development teams are unable to modify their 6-month release cycle. So we're going to need to plan project phases backwards from the release date that will allow us to align with the ERP release. And then future releases that require ERP updates will also have to be planned in sync with the ERP release cycle, and that will prevent us from adopting a pure agile methodology. And then there may be data corrections that need to be performed repeatedly in source systems. Some examples may be invalid emails, invalid phones, duplicate data that needs to be reviewed by an individual. So what we'll do is assign data stewards by system and data entity and provide a report of data quality issues from each test migration. I am assuming that businesses have roughly an average of 3 properties, and that affects my data volume calculations. For systems in play, we're going to have a single org Salesforce approach with multi-language and multi-currency. This will allow us to unify their global business processes. We'll utilize a data warehouse that has support for Tableau CRM connectors as well as OData in case they want to use Salesforce Connect in the future. Our process for archiving data will be to extract it from Salesforce, insert it on the into the data warehouse, and upon successful acknowledgement, delete the data from Salesforce. And at a later date, that data can be synced into a Tableau CRM data set for analytics. For meters, they have a combination of legacy meters that communicate with a radar reader that then will call an API in the ESB, and smart meters that will be able to connect directly to the ESB to submit readings. And the ESB will be integrated with Salesforce. We'll also have real-time integrations to delegate the calculation of tariffs, discounts, and bundles to Power Sales, and integrations with the PDF generator tool to get documents. They have one ERP per country that will also be integrated via the ESB with Salesforce. Additionally, we're going to select and purchase an MDM tool that supports both registry and consolidation style MDM strategies. And I'll speak more to that in the data migration plan. Okay, so coming to the ERD, just quickly looking at the key. Black lines here are lookup relationships. Red lines are master detail relationships. Vol indicates the number of rows calculated, and LDV indicates large data volume. In other words, projected volume of 5 million or more retained within Salesforce. So we'll come back to this as I go through the business process requirements. So beginning with key customer management, we have certain key customers that will be stored as accounts and contacts, business accounts with multiple contacts, and then the location custom object will be used to track sites and properties. They need to be able to enroll these key customers, begin notifications with the customer, and then provide offers for different tariffs with the customers. We're going to utilize the opportunity object to indicate the opportunity to promote a customer to a key customer, and then quotes for each tariff offered. And then by the end of the process, the customer switched to a different, more business-oriented tariff, and a new contract is signed. It will be reflected by the contract object. And I'll note that tariff details are sent to the country's ERP, which facilitates the switching process. So we won't store tariffs in Salesforce, only an external ID on the account record. So coming to the data model, we have accounts, which can be household, business, or partner accounts. All of these are not person accounts. Those won't be utilized. An estimated volume of 6.7 million records. Contacts, estimated volume of 15.5 million records. Those are both large data volumes. Also, we have opportunities, many to one to account, and then quote, master, detailed opportunity, and also has a lookup to account, and both of these objects are related to contracts as well. Contract has a standard master detail relationship to accounts. Okay, so coming to customer services, customers need to be able to create inquiries or complaints, which will be tracked in the case object. Um, the system needs to be able to not only collect real meter readings, but also create forecasted meter readings for the next month based on the previous month's reading. Both of these will be stored in the meter reading big object with a relationship to the asset object for the meter itself. Um, and then customers need to be able to view their past invoices and payments and view a PDF version of their invoices. So I'm assuming that the ERP handles invoicing. So that will be performed. The ability to view those invoices will be performed via real-time integration with the ERP. We'll store account and asset IDs in the ERP to make that integration possible. And then we'll have the payment method custom object, which stores tokenized payment information in Salesforce, and the payment big object for storing a record of payments submitted. And in case an energy failure is reported, a critical incident will be created and assigned to the right maintenance partner. So that will be a case with an account lookup to the maintenance partner. Okay, so bearing that in mind, we have the location object, menu to one to account, with an estimated volume of 8.1 million location records, estimated volume of 10 million asset records. Both of these are large data volumes. And then meter readings, because we have some factor of 10 million per day. So depending on how many readings there are, it could be one per hour, and then that would be 24 times 10 million per day. This is going to quickly get into the hundreds of millions and even billions of records. So our large data volume mitigation has to be storing this as a big object. Payment methods. Our custom object, also large data volume, because at least every one of our customer accounts is going to have at least one payment method. That is also going to be a factor of 6.7 million rows. And then payments, we'll have a lookup to both accounts and payment methods. That will be a big object because if you multiply the number of accounts by 12, you're going to have at least 80 million payments per year. And so this object will scale very quickly, and a big object is a good way to store data that does not change after it's been recorded. All right, coming to scheduled manual readings. Field service agents drive or walk by residential houses that have a legacy meter. And so they will have a service appointment to indicate that they need to come to the house and take a reading of an asset. So service appointment has an asset lookup. They're looking to optimize visiting times and travel costs, which is why we've chosen to implement an FSL object for that. Then we have scheduled automatic meter reading. The data model is no different, just the means by which the asset and meter reading are recorded. Coming to customer registration, customers are registered by activating contact records as users. They then have a lookup to the account and the contact. They need to be able to expose their products to unauthenticated users. We'll use the product to object, and users can subscribe online to services by providing information such as the number of household, expected power consumption, and address details. Those will be recorded as an account, contact record, and location records. And then the system will determine and display the right tariff for the customer via real-time integration, the ERP. And then the user needs to access the customer portal. And then customers need to be able to invite one or more contacts to the portal to co-manage a particular property and contract. So this means that even households cannot be person accounts because there could be multiple contacts related to the same household account. Coming to field sales agents visit potential B2B leads, walk them through the different offers available, using a handheld tablet and they'd like to track all activities undertaken with the client. So this is actually going to be not account, but a service appointment related to a lead, and then tasks for all activities undertaken with the client. Um, and then they send email surveys out. We can utilize Salesforce surveys for designing and sending these surveys out. Okay, so talking back through the object model, you see we have service appointment related to asset. It can also be related to a lead and to a work order or work order line item. There is a mention of users that perform maintenance. It's not a detailed part of the business process requirements, but in the case where maintenance partners are performing maintenance, we'll have a service appointment related to a work order. So coming to our LDV mitigations, customers have 6.7 million records, and then contracts and payments are both a factor of 6.7 million records, and assets are 10 million records, and locations are about 8.1 million records. So our strategy for long-term mitigation is to archive inactive customers and their related records to the data warehouse. That means if they have had no active contracts for at least a year, that account and the associated objects I just mentioned, including contacts, contracts, locations, and assets, will be archived to the data warehouse. And then the short and midterm mitigation for large data volumes is to utilize skinny tables and custom indexes to improve the performance of reports and SQL queries. Then we have objects like case, service appointment, work order line item, and task. These are in some way a function or a factor of the volume of assets and accounts, and they're constantly being created. So you have some factor of 10 million service appointments created per year, some factor of 6.7 million tasks created per year. So these will be archived to the data warehouse quarterly as our long-term mitigation. So if some record is closed in Q1, at the end of Q2, we archive it to the data warehouse. And then our short and midterm mitigation is again to use skinny tables and custom indexes. For users, we have 15.5 million estimated contacts. So our mitigation to abide by the limit of 10 million high volume community users is to automatically activate primary contacts, but only to activate secondary contacts as users as needed when determined by the primary contact to keep that volume below 10 million. We can also extend the high volume community user limit. That does have performance implications, but can be done as long as we're not greatly exceeding that limit of 10 million records. Additionally, we'll deactivate account user records as the associated account and contact are archived to the data warehouse. And our short-term mitigation is to use high volume community licenses. Okay, so coming to the data migration plan, just briefly looking at the requirements here, they have over 80 million customer records across their CRMs, but the data is so duplicated, there are actually only about 6.7 million unique records. They need to deduplicate these records and link them to the ERP records. Similarly, they have across all their systems 200 million meter records, but they expect the volume to be around 10 million. So for data migration, the first thing that we're going to do is use an ETL process, use our ETL tool to extract customers and assets from the ERP and CRM systems and load them into an MDM. We'll then deduplicate and match these records. As a part of ETL, we'll create a golden record for customers in Salesforce and then use a registry style to provide a global ID and update the customer record in the ERP. So what that means is we deduplicate the customers from the CRM and then match them to one or many customer records in the ERPs and update the ERPs with the unique ID that we generated for the golden customer record. And then for the assets, we're just deduplicating them. We're loading both the deduplicated customer and asset records into source tables in a MySQL staging database, and we're also extracting the remaining CRM and ERP data and loading it into source tables in a MySQL staging database. We'll have a stored procedure to transform and cleanse and load data into target tables that reflect the structure of Salesforce. that reflect the Salesforce data model. And then we'll have an ETL process to extract records from the staging database target tables and load them into Salesforce. I've given an order that will allow us to ensure that only to ensure that records are loaded in order of relationships. We'll also use you know bulk data loading processes, lean data loading practices. Sorry, utilization of the bulk API in parallel mode, ordering by foreign keys to ensure that record locks are kept to a minimum, deferring sharing calculations, and using custom settings to switch off process automation like triggers. I've noted too that only open cases, work orders, work order items, and service appointments will be loaded into Salesforce because we archive the closed ones to the data warehouse. Um, and additionally, we're going to perform ETL to load all of the data that does not meet our criteria to go into Salesforce and load it into the data warehouse instead. All right, I'd like to come to our project development requirements. So they'd like to start realizing value quickly and get Salesforce functionalities as soon as possible. Because of their release date limitations, I'm recommending a hybrid of Scrum and Waterfall. So they'll have a discovery phase where we gather a backlog of user stories, identify which of them are MVP stories, and then we'll have a design phase where we create our system level design artifacts and identify dependencies. We'll have a build phase operating in 2-week sprints where we pull the highest priority MVP stories and start building them in a cyclical fashion, designing, building, and testing them in a cyclical fashion. We'll have then a sit and UAT phase followed by training and then a release to production. This will all be planned backwards from our target release date. We have a risk that I mentioned regarding the 6-month release cycle for ERPs. Customer support is used to high productivity, and they have a regulatory requirement to handle calls in no more than 10 minutes. It's going to be solved with case escalation rules and a CTI integration, such as the CTI App Exchange app in Salesforce. And then they would like to get support in identifying potential project risks. This will make more sense as we look at the governance structure, but we're going to track risks in our project management software. They'll be reported by a program manager and owned by a program owner, who is a mid-level executive at the customer organization. They'd like a clear, traceable way to track features developed throughout the project's lifecycle. So we're going to track our backlog, user stories, all that in our project management software, and we're going to choose one that is integrated with a Git host so that pull requests can be linked to user stories and create full development traceability between stories defined and development delivered. They're looking for recommendations for the right environment management strategy to ensure tests are executed at each stage and to ensure the reliability of their integration interfaces. That will become clear as we review our environments and CI strategy. And they want an appropriate methodology to manage the project delivery and technical governance. So that will flow into our hybrid Scrum waterfall methodology. Additionally, they have recently acquired a company that works in renewable energy. They manufacture and install solar system panels as well as electric batteries. They'd like to know whether they should plan to merge the Salesforce instance with theirs or keep it separate. Since the business processes and the data are completely separate, a diversification model is appropriate. That means that we're going to keep our Salesforce instances separate. However, to create a 360-degree view of customers, we can evaluate whether or not there would be ROI in integrating their customer data and also having a real-time view into opportunities and service data from the other Salesforce org using Salesforce Connect. Coming to our governance structure, at the top, we're going to have our executive sponsor responsible for final budget approval, as well as defining the vision for what needs to be accomplished with each release. We'll have an executive steering committee. The executive sponsor and the program owner both will attend this. It'll be a place for escalation to occur, a place where the budget can be formulated, and where the strategy, in other words, the milestones that need to be reached with each release, can be discussed. The program owner will be a mid-level executive that owns risks and issues as well as the project schedule and can report up to the executive steering committee if they see any problems. There will be a program manager that operates as part of the COE that will also report to the program owner and will inform them of risks and issues. We'll have a center of excellence for the enterprise, a project management office. Will set project management standards across the enterprise and also create the charters for all the other governing bodies in the COE. An architecture review board will review the viability of the system design as well as proposed changes to the system. A change control board will act as a filter. All changes need to be run by the change control board, and then they'll decide whether or not it also needs to go by the architecture review board before it can be promoted to our UAT environment. We'll have a product steering committee. This is a place where the product owner can hear future requests from business stakeholders, typically on a monthly basis. And then a change management group that is responsible for assembling communication materials and devising a communication strategy and training end users and admins and IT and developers how to use and maintain the application. And then we'll have our work streams, rather our Scrum teams that report up to the Center of Excellence, getting their features from the product steering committee and running their changes by the change control board and the architecture review board. Coming to our environments and CI strategy, once we get into the build phase, developers will be branching from the develop branch, creating what are called feature branches, creating a scratch org for the feature, performing their work in the scratch org, and then submitting a pull request against the develop branch. And this will work similarly when we get to the release branch and the hotfix branches, where we branch from and PR into that target parent branch. When a pull request is submitted, our CI job will create a scratch org test deployment that has to pass. Apex and LWC unit tests will have to pass, and requisite Apex coverage will have to be reached. It'll run static code analysis and attach an HTML report to the build. It will then destroy the scratch org, and a tech lead or senior developer will have to peer review and approve the pull request. Once the pull request is completed, then our continuous deployment job runs. It installs dependencies, deploys unpackaged metadata, performs a unlocked package build, and installs our unlocked package in the target org. So what we're going to have is one repository that will have a project path for an unlocked package and then a path for unpackaged metadata. And unlocked packages allow us to have smooth rollbacks as well as to deprecate metadata more easily. So when a feature is first developed, it will be deployed to our first Dev Pro sandbox, where the developer is responsible for smoke testing their own work to ensure that it works well and when integrated with the other features developed by the other developers, and that they didn't forget to commit anything to their feature branch. And by the end of the day, they either have to pass smoke testing or revert the pull request. At the start of each day, in order to create a stable QA environment, the QA manager will manually initiate via our CD pipeline a deployment to the Dev Pro 2 sandbox. And that is where the QA testers will QA test stories that were completed the prior day. And this is to ensure that the features meet the acceptance criteria agreed upon by the business. Then, after each sprint ends, at the start of the next sprint, the QA team will begin regression testing the application to ensure functionality developed during the sprint did not break anything developed in a prior sprint. And this repeats throughout the build phase every 2 weeks. When we get to our test phase, we'll then create a release branch with a version number. The release branch is deployed to our full copy sandbox with each commit. There we'll perform system integration testing from test scripts agreed upon by the QA manager and our technical leads that will ensure the application, the integrations, and the data migration work smoothly together, followed by user acceptance testing, where power users from each user group or each persona perform their end-to-end workflows to ensure they can do their job in the system. If bugs are found in either of these test cycles, we'll branch from NPR into the release branch to fix them. And once all the bugs have been closed out, we'll merge the release branch back into the develop branch so that If development has begun on the subsequent release, our bug fixes are incorporated in the next release. We'll then manually initiate a deployment via our CED pipeline to our DevPro 3 sandbox. This is where training will occur for end users. When it's time to release to production, the release branch will be merged into the main branch and tagged with the version number that will initiate a deployment to production. And then if a critical issue is found in production, a hotfix branch with a version number will be created. Developers will branch from NPR into that hotfix branch. With each commit, a deployment occurs to the partial sandbox where a QA tester tests the bug to confirm that it was fixed, that the associated story user acceptance criteria passes again, and then they will perform a limited regression testing script devised by the QA manager to ensure that related functionality was not broken by the bug fix. And this hotfix process will happen as often as needed, and the hotfix branch is then merged back into the main branch and the open release branch and the develop branch to ensure hotfixes are never rolled back. For tools, we're going to have our Git CLI and host, our PM software, and our CR pipelines tool. They'll get good value out of a platform that supports all three, and so Azure DevOps or GitLab are good options, as well as the Atlassian suite. We'll utilize Apex PMD. That's an open source library for static code analysis. And then SFDX is a command line wrapper for the metadata API. It helps with deployments as well as running unit tests and certain data tasks. And then a SFDX plugin referred to as the Salesforce Data Move utility, which will help us stage Scratch orgs and QA environments with test data that will help with consistent staging, consistent test data, setting up user personas and the like. And yep, that's everything that I wanted to cover. We have 3 more minutes on the clock, but I'm going to add that to my QA time.